In this practical, we will be comparing a normal half-wave rectifier with a precision rectifier. The difference between a rectifier using diode and precision is that diode rectifies a signal. If it is germanium, then it should be greater than 0.3 volts, and if it is silicon, it should be greater than 0.7 volt. It will only rectify the signal after the cut-in voltage is received. But in precision, a value as small as 1 millivolt is also rectified. So let us see through the experiment if it is possible. So the first circuit we see over here is a half-wave rectifier using diode. This is a half-wave rectifier using diode. So when the input signal is coming for the positive half cycle, after the cut-in voltage, the diode is forward biased and the output becomes equal to the input. During the negative half cycle, the diode is reverse biased and there is no output. So the output should be approximately input minus the cut-in voltage of diode. This is a germanium diode, so it should be input minus 0.3 volts, the cut-in voltage of germanium diode. So the input, we are setting it to 1 volts peak to peak. So after that, it will rectify the signal, run it, and let's observe the output. The red one is the output, purple one is the input. The first thing which we see is that rectification is happening only during the positive half cycle. Approximately the output should be equal to, it is 1 volt minus 0.3, so approximately 0.7. So it is coming out to be 0.576. It is coming out to be 0.576. So it is rectifying the signal. The same, now we need to compare this with the precision rectifier. Precision rectifier is making use of operational amplifier. It works on the principle of comparators. That means the output, uh, uh, the diode will be forward biased at plus Vsat and minus Vsat. So let us see, over here the output will be exactly same as the input because both the terminal of the op amp have the same voltage. So non-inverting terminal is having voltage same as inverting terminal, therefore output should be same as input. During the positive half cycle, the diode is forward biased and therefore output becomes equal to input. During the negative half cycle, the diode is reverse biased, no current flows, therefore output is 0. So let us see whether we get exactly 1 volts over here. First, let me set the input to 1 volts peak, run the circuit and measure the output. Let us adjust the output. Change the color of input. You can change it by segment color. So over here also we can observe that the input is both positive and negative half cycle, but the output is only for the positive half cycle, negative cycle it is not there, so half wave rectification is happening. Let us measure. So for channel A, it is 0.997, so approximately 1 volts. So as we said that output should be same as the input. So output is, for the positive half cycle, it should be 1 volts. It is coming out to 0.997 volts, which is approximately 1 volts. So if we compare the precision with a normal rectifier, for precision, the output is input minus the cut-in voltage, but for precision the output is same as the input. This is the first part. Second part, we need to see that for a signal as low as 100 millivolts, do we get the input? So Let us just change the input, and for 100 millivolts over here it will be 50 millivolts because it takes the peak value. And now let us run it and see whether we are getting the output. Change channel B to millivolts range. Input is there. Let's see if we get the output. We are getting the output, but let us measure it. Although we can see it, but from the value we'll come to know how much it is. So if you see, it is 1.16 millivolts. We are giving 100 millivolts and output is 1.16. That is nearly 0.001. So it is nearly 0 volts. So it is not doing any rectification. But in precision rectifier, even this small value will give us rectification. So let us change for the precision rectifier. Let us make it 50 millivolts for 100, and now output should come out to be same as the input. Let us change the scale for both the channel. First we'll change it for the input. We can see the input full wave, and output will also be in milli. So we can see that our output is also there. A negative half cycle is not there. During the positive half cycle we are getting, and it should be approximately 50 millivolts. So we are getting 51.543 millivolts. So in this way, even for a small signal of 100 millivolts, the op-amp is able to rectify it. So therefore, it is called as a precision rectifier. So the comparison between normal rectifier and precision is that the normal rectifier circuit using diode does not rectify the signal lesser than its cut-in voltage, but in precision rectifier it is able to rectify a signal as low as 0.001 volts also. Thank you.